so only one no, and everyone else has installed it. Okay, I'll walk you through the installation very fast. I don't want to take up the whole class time on it. Can you see my screen, or is it not showing up anymore?
I just see a picture.
Okay, let me do the screen share again. Okay, hopefully you can see the screen now.
Yes.
Okay, to install, you have to log on to Blackboard, which you already are there. And in the landing page, you will see some picture like this. Everyone's Blackboard looks slightly different. Well, not everyone, but it looks slightly different for instructors versus students. This is what I see when I log on. But in the Your Links bit up here, you'll see several links available, My UEA, Library, eVision. If you click on Show All, other things will show up. It will expand. And from there, you can click on Show All, and one of the things that will show up is UEA software download. And in the UEA software download, you then click on it. And this is the alternative direct link that you can use to get to it. But once you've gone through the download button, STATA will show up right over here. So let me just move to here. Okay, that might disconnect me if I do that. So I'm going to not try and do that live because it will disconnect me. And in the STATA, once you click on the STATA, these are all the software that you can install on your home computer. You will get a lot of information over there, but most important is what's written over here. These are the terms that you need to copy down: serial number, code, and authorization. Just do copy paste somewhere on a notepad, and then click on Windows STATA 17 or Linux 17 or Mac STATA 17, whichever type of operating system you use. If you were using Windows STATA 17, then you will, for instance, get the zip folder. And with the zip folder, you can do Save As, Save File, then click on Setup STATA exe, and then follow Install Sheet Visit. Follow the instructions on the Install Sheet Visit, and then you will get a screen where you have to enter some information. Enter your name, university name, serial number, code, and authorization. These three codes are the ones that we copied down from above. And then that's about it. After that, you can start using STATA. Okay. So given that most people have said yes to having already installed STATA, I'm going to move on and fire up the first STATA lecture. Okay. Now, in this folder, you can see several files over here. We're going to work with some of these files today. The one that I will walk you through, and my entire lecture that I'm talking about right now, one, it's going to be recorded. Two, everything that I do is also available in this file called Introduction to STATA. So if you click this file, you will see a PDF that walks you through how to use STATA. You don't need it right now. You can have it open in the background if you want, because I'm going to actually start doing all of these things. That's one thing I wanted to tell you about. That whatever I'm talking right now, if you miss any part of it, don't worry. You have two things available. One, a full video of this lecture, and second, a planned exercises that are written in this introduction to STATA. What we will also be using through this lecture is this one data set called data01 gooch-06b04. We'll refer to this in a bit. I'll come back to that. Don't bother with it right now. For now, I'm going to just basically look at the actual lecture on this. Okay. Now, while I'm doing this thing, I would also request that if you have any questions or comments, please, if I ignore it, it's because I'm keeping my eye on the other screen as I'm walking you through it, through this screen, as well as having to open a session of STATA on my own computer to walk you through it. But if you have any questions and it looks like I'm ignoring it, it's not because I want to ignore it, it's because I'm sort of unaware that you've written something there or raised your hand or something. So please, if that happens, just unmute your mic and then be able to just come in and say whatever you want to. Okay, you're saying you cannot see my screen? We currently see the license initialization. That is odd.
Hello?
Yes?
I don't know about everybody else, but I'm currently viewing your screen, which was when you was regarding how to set up STATA. So all the Blackboard links that you have just mentioned, although I understood what you were saying and I found them, I could not see, yeah, I can now. I can now see what you were referring to, but I couldn't previously.
Okay, then it means it's coming with a delay. I'm not sure why, because I have a second screen open in which I'm trying to view in the second stream what it's telling you guys can see, and there it's showing me that it's got a web page open that shows introduction to STATA, and it's been on for quite a while. So I repeat what I said. I apologize that I don't know why you weren't seeing it earlier. Let me just say that everything that I'm doing over here, I'm going to walk you through a set of notes that I've pre-written. They're over here, but a full copy of these notes is also already available as a PDF in the same folder called Introduction to STATA, or STATA data sets and instructions. So you'll find a copy of that. So anything that you miss, I wouldn't worry too much about it. You'll have the whole thing, any specific command. Okay, so the idea is we're going to learn how to open STATA, how to understand its data interface, how to do data entry, either physically or importing certain data sets from things like Excel, and then working with these data sets to generate descriptive statistics. And towards the end, we'll also do create a do file. So on Yeka wrote STATA is still not installed. Okay. You might, if it takes too long to install, or if it's taking too long to download, you may have to just watch this tutorial today and then try and download it after the class and try to replicate whatever I did over here. Like I said, all instructions will be available to you. So one other thing that I want to warn you about, that this tutorial is shown in STATA version 12.1. What you have just downloaded is STATA version 17. There is going to be absolutely no difference in the commands that you use. Just small cosmetic things might look slightly differently. And the version that I'm going to open up on my computer, the home computer that I'm using right now, is going to be using STATA version 14. So version 12, version 14, and the one that you've just installed, which is version 17, they should all look or behave exactly the same. So don't worry about it if you see 12.1 written over here as opposed to 17, which is what you'll see on your screen. Okay, having said that, I'm now opening up my STATA, copy of my STATA, and I'm going to move away the screen so I can walk you through bits of it. So you can adjust the widths and lengths of your STATA when you open it. Yours might be looking like this. There might be a very small window down here, command window. You can make it bigger or smaller as you like. And when you open STATA, you get these separate different windows. On the left over here, as I'm showing, is essentially your command window. So this window on the left records the commands. You issue the commands down here, where I'm typing like this is where you type your commands to STATA, whatever those commands are, whether they're about printing something, whether they're about doing a calculation, whether they're about issuing descriptive statistics, or whether they're about loading the data. So you issue them over here in this window, and then in the window on the left, you'll see a history of those commands show up. When you end up loading a data set, that data set or the variables in that data set will show up in this window on the right, which says variables up here. And below this tiny window down here, which you can also make longer if you want, if you selected any one variable out of it, it would give you more information about that specific variable. The rest of the setup in data is pretty standard in terms of what it looks like. And just give me 1 second, I want to check one other thing in terms of what's been posted on the website. Okay, so in here is the results window. This is the variable window. On the left is the command window, and down here is the actual commands that you give. Now, notice this bottom left corner where it says on my screen, C users Bukhari documents. I'm going to bring this PDF up so you can see it more clearly. In your own window, you see the C users Bukhari documents. This is the directory in which, on my computer, STATA is operating, or at least when I made this manual. You can see over here on the actual STATA it's showing the same thing. On your computer, it might be showing a different location. If anybody is seeing some location over here on their computer in the bottom left panel and you want to share it, please type your command over here in the chat window, or whatever you think you're seeing over there. If it's different from C users, your name, and documents. Your name is whatever your name is registered on your computer. Okay. Reason why it's important to note down this location is because by default, this is where STATA is going to look for any data sets that you want to work with. So when you issue a command saying load a particular data set, and I'll show you how those commands are issued, STATA will look in this location. We can change the current Active Directory, or we can tell it to look for data in a different place. Similarly, when you're trying to save something, whether it's a command or a picture or output or anything like that, it will also save in whatever is called the current Active Directory. So does everyone understand what current Active Directory means and what it stands for? If you have question about it or have not understood, let me know, because this is going to be pretty important in finding your data sets and making sure that they're downloaded in the right location. Okay. So that's the first part of it. Then the next is, if you look at the buttons on the top, they're pretty standard, like in any Windows-based software. You have the file, edit button, data button, graphics, so on, and you can guess what most of these are going to do. For instance, if you click on open, it will allow you to open either a data set or what we'll see later on is a do file. Okay. Then there are different types of files that are associated with STATA. So just like with, for instance, with Microsoft Word, you have files like DOC or DOT or DOCX that are associated with it, or with Excel you have XLS or XLSX or XLA. Similarly with STATA, there are different types of files that are associated. These different types of files are file names with the extension DTA, the extension ADO, extension do, extension log, extension SM, and extension GPH. And their meanings is displayed over here. So a data set will be in a file called whatever name you've given it, .dta. When you write your own code, you can save it, a collection of those codes, in what's called a do file. That's over here. A ADO file, on the other hand, is like a do file, but a very extensive program that some third party may have written that helps you do certain tasks. And those are usually available for download from different places, and they become part of the STATA program itself. Log essentially is this window that I was showing you where the results go. The log file can help you keep record of all the commands that you issued and all the outputs that came from it. And it will save it in a plain ASCII text format. Alternatively, log can also be saved in SMCL format, which is an internal STATA format. And not only can you save logs in there, but their help files also come in the SMCL format. And GPH is their graph file, which you can then convert to either JPEG or PNG or PDF or EPS or whichever format you like. But GPH is STATA's internal format for displaying graphics. Everything clear so far? Okay. Again, like I said, if you have any questions, please feel free to interrupt and ask questions, or if something again happens where my screen is not showing up or not displaying, please do let me know. All right, you can use STATA before we start using it as a powerful statistical software. You can also use it as a simple calculator on your computer. So to use it as a simple calculator, you have to use the command called display. Okay, and if you write display and then issue some simple calculation as you would on a calculator, it will give you an answer. For instance, if I write display 2 plus 2 and hit enter, it displays over here. The answer is 4. You can try it on your own computer and you should get something, well, you should get exactly the same answer. Okay. The other thing about STATA is that when commands are issued, like this one over here, display, you can actually abbreviate them up to the point that they are unique. As it turns out, in STATA, there is no other command that starts with the letter DI and then starts differentiating with SPLAY onward. So you could just write DI 2 plus 2 and that would also work. Okay. We can also do data entry manually. I've given how to enter data manually over here, but I'm going to skip that because manual entry, while I explain it over here, is relatively rare in this day and age. Most often than not, you will get data given to you as either a previously saved STATA data set or some sort of a spreadsheet or a comma delimited file or something like that, which you can directly import into STATA. So I'm going to go over and show you how to import using first the simplest command, which is from copy paste. So to do that exercise, I'm going to open Excel and make a dummy data set over here, pretending that as if it's a real data set. Now, I'm not going to use the same numbers that are listed in this PDF. I'll just make up some other numbers. I'll give them some names like Y1, Y2, Y3 as 3 different variables. And I'm going to fill these with some random values. So rand times 10 integer. You don't need to worry about the Excel commands. This is just my way of generating some random numbers. And I'm going to copy them and paste special values so they don't change. Okay, so here's the numbers that I've generated in Excel. Now I'm going to pretend that this was some real data set and somebody had given it to me to use for analysis. The question is, how can I get it inside of STATA, and then how will I use it? How will I use it within STATA comes after this part where I show you how to bring it into STATA. So the simplest way to bringing it in, as long as it's not a very big sheet, is you select that data and then copy it. So I right-clicked in Excel and click on copy. So it's now selected for copying. Now I go into STATA, I go to data, and then you'll see two things over here, describe data and data editor. So since I don't have any data in it, I'm trying to bring it in. I would go to data editor, and in the data editor, I have again two options, edit or browse. Well, there is no data there to browse, so I'm going to click on data editor edit, and that will allow me to directly copy and paste the data set that was in Excel. Let me click on edit, and this type of spreadsheet shows up, which shows that there's absolutely nothing in this data set. Now remember, I've already copied in Excel this stuff along with the first row called y1, y2, y3, which is the name of the variables. So I come here and I click on Control V, and this window will show up. What is this window doing? It's saying the first row on the clipboard contains values that can be used as valid variable names. Do you want to treat the first row as variable names or as data? So what do you think it should be the answer over here? Please type it in the chat. Should it be variable names or data? Variable names, correct. So I click on variable names, and you'll see that suddenly y1, y2, y3 appeared in the border over here, and the values have suddenly appeared over here in as the different rows. And those are the actual values. I'll click on this cross. That will not make the data go away. It will just make the screen go away, but the data is still loaded in STATA. So not to worry. I'm getting rid of the Excel because I don't need that. Look at this over here, this window I was telling you about. That here, it's telling me that there are 3 variables listed over here in this data set. And if I do issue the command describe, describe is a command in STATA that gives you information about the meta information about the data set in the memory. And I click on it, hit on it, it tells me that this data set contains 20 observations. It has 3 variables. The size is 60 of this file. And the names of the variables are y1, y2, y3, and they're all of the numeric type. In fact, one of the variables also has a label called y2. Okay. So I brought this data back in here, and you can see that we can bring the data directly this way, and then we can manipulate it. Now, I'm going to get rid of this data set and work with a different data set that I'm going to show you how to download and use. So first, to get rid of this data set, what you need to do is issue a command called clear. So C-L-E-A-R, it's all lowercase. Type that and click on enter, and when you enter, you'll see that this stuff over here on the right hand side will disappear. The y1, y2, y3 will disappear. Okay. So I'm about to hit click, I'm about to hit enter. Notice y1, y2, y3 will disappear. There, gone. Now the data has the state has no data set loaded in it. Okay. So the next bit is a little bit tricky. This is where this part, variable label. I'll describe that in a bit later, but basically it's the short that you could call a variable x or y or z or y1 or y2, and it may have specific meanings to it. Like for instance, y1 may be income per capita. So you could issue a label in front of it in the data set, which will say income per capita, so that when you're printing or looking at those variables, you can remember the meaning of it. And I'll show you how to put labels on in a bit. Okay, so the first thing we're going to do is bring in a data set, but the part that I mentioned over here, which was noting down your, your Active Directory, current Active Directory, that's going to play an important part. So keep an eye on where this Active Directory is, and now I'm going to show you a data set that I want you to download, and make sure you put it in the directory which is currently showing in the in the bottom left corner of the window over here. Okay. So the data set that we want to bring in, its name is Gooch tab 06P04DTA. It is not located in the location that this thing is saying, because this was written on my home computer. You will get a copy of this data set from Blackboard itself. So let me show you where it is in the Blackboard. If you go into week 2 probability, and from there into STATA instructions and data set, you will find the data over here, data 01, which is Gooch tab 06P04.dta. Now don't click on it. What I want you to do is, instead of left clicking on it, I want you to do a right click on it. And that will give you a link like this, which is save link as or download as or whatever. When you do that, an option shows up where to save the data set on your computer. Don't save it in an arbitrary location. I would like you to save it precisely in the same location where the current Active Directory is. So current Active Directory on my case was over here. C users document. Let's just make sure it is over there. C users Hari, and then it said documents. Right? This is what mine was saying. C users Bukhari documents. So I'm going to download mine over here. You should download in your case wherever your current Active Directory is. So I've set it over there. I'm going to click on save, and it will put this data set over here in this folder. Okay. Anyone confused about this bit? Okay. Please write in chat yes if you have downloaded the data set as I've just explained into the current Active Directory. If it's not so and you want me to show you how to download again, let me know and I'd be happy to repeat. Okay. Looks like 1, 2, 3, 4, 5, 6, 7 people have done so out of 26. Seven have done so. 8. Okay, one person wants me to repeat. I'll do that in a minute. Gianbo. How to download. Failed to do the license initialization. Okay, your license initialization part, I can't do it right now. You'll have to follow the instructions I gave earlier after the class. Until then, just please watch how I'm doing it. There's a recording available, so then you'll be able to follow through. Let me just show you once again how to download. So there are 2 parts to downloading. One is finding the data set on Blackboard where it is located, and 2, downloading it in the correct location. The correct location is whatever it says on your STATA left window, current active directory. And in terms of how to download, or rather where to download from, you go to the folder over here in week 2 probability and statistics. You go to the folder called STATA instructions and data, and there you'll see all the data sets. The one you want to download is called Gooch tab 06P04. This is the first data set. You right click on it to save link as. It will ask you where to do it, where to save it, and here you must choose the directory that was the current active directory. Okay. Okay, if it says your serial number and code are not valid, you might have typed it in incorrectly. So best thing to do is copy and paste it. If you copy and paste it from that location, it will be much easier, because there could be O's that are written as zeros or zeros written as O's, and other small typing errors can also take place because it's pretty long. Okay, great. So you've got the data set, Janbo. Okay, I'll move on. Now, to load the data set, sorry, where did it go? To load the data set, what you need to do is issue a command to load it, and that command is called load, or use, sorry. So you use the use command, this command, use, to load a data set. So what you will do is you will type literally use and then the name of the data set onto your computer. So here I'll do use Gooch tab 06P04. STATA is very case sensitive, so do not use uppercase U or uppercase Gooch or something like that. The case has to be exactly the same as the name of the data set. So type that and hit enter, and you will see that a data set has been loaded. This window on the right is showing you that there are 4 variables in it. They're called CM, FLR, PJNP, TFR. And Debbie, I think, asked what is a label. Label is showing up over here. It tells you that the variable called CM stands for child mortality, that the variable called FLR stands for female literacy rate. The one called PGNP is per capita GNP 90, and TFR is total fertility rate. So it's a little bit more detailed information on what the abbreviated variable name stands for. There's also another label over here that you'll see on this part of the screen in the output. It says in parentheses, Gujarati table 6.4 : fertility and other data for 64 countries. What does that mean? That's the label on the overall data set, and it's basically telling you what is the source of the data. The source of the data comes from a textbook by Damodar Gujarati. It is a table taken from that textbook from chapter 6, specifically chapter 6, table number 6.4, and it says that that table in that textbook provides fertility and other data for 64 countries. It's an old data set from 80s or something like that, perhaps even older, because we're not basically interested in right now working with the latest data, but rather simply understanding how to use a data set once it's there. Okay. Does everyone have the data set loaded up except for obviously the people who have not been able to install STATA? Outside of that, okay, so Zach certainly has it. I don't know about the others, but I'm going to assume that others also mostly have it by now. Great. Okay. Now, if the data set had been downloaded not in the active directory, but in a different directory, you could have also done a couple of other things. You could have either put the use and then the full path of the directory wherever you downloaded it, but you would then have to put it within quotes. So that would be the alternative way. Here we already downloaded it in the right directory, so we can skip putting the full path there. Another way to do it is you can, if you put it in a different location, you can change the directory or CD, issue that command, and it will change your active directory. So if you had downloaded the dataset onto a thumb drive, for instance, then you would do, and thumb drive was called E drive on your computer, for instance, you could do CD E colon, and that would point over there, and then type use Gooch from there, and it would load it from E drive. Okay, so that's just some extra information over here. It doesn't really matter. Now, the first command you're going to learn about is describe. If you type describe and hit enter onto your computer, you should see a screen like this. What it does is it provides, like the last time, more information on the table about the data that you've loaded. If you hit describe and hit enter, again it is lowercase, it will tell you that the label on the dataset, where it comes from, what it's loaded, the label on the dataset, when the dataset was created. This was happened to be in 2012 that I copied or made a STATA version of this dataset. It has 64 observations, 4 variables, size is 576, and it says here are the 4 variables in it, and these are their labels. We don't have to worry about that storage type for now, but essentially there are different ways of storing data. It can be a string, it can be integer, it can be a byte, it can be a floating number, which keeps track of, decimal points, different ways of recording the data in the computer, and then they take up accordingly different memory. This particular data set is just these 4 types, well, these 3 types. And here it says sorted by, and there's nothing written over here, means that the data set has not been pre-sorted with anything. Okay. So the simple command was describe. And it gives you this output. Now, you can also do another type of command, describe, for instance, and type in the name of some selected variable, any variables you like. For instance, I'm going to do CMN FLR. Okay? If I do that, it will provide not the information about the full data set, but it will provide information about these 2 specific variables. And the difference over here is that STATA is often, the commands in STATA are often issued by first typing a command name and then following it with on what that command should apply to. If you don't type what that command should apply to, it tries to interpret as broadly as possible. So if you just write describe, it tries to apply it to all the variables, and since it's applying it to all the variables, it tries to describe the whole data set. Hence, this information or the labels information also shows up, and how many observations there are in the data set. So this part shows up. If you do it just to a couple of variables, it will provide you more relevant information about just those variables. Okay. I said that you can also abbreviate things, so I can also write DESC and then type FLR, TFR, and it will still work because describe is abbreviated to DESC as some sort of a shorter version. Next is 3 other codes that we'll look at. First called codebook, another called inspect, another called list. So go ahead and type codebook for any one of them. I'm going to write CM. And when you do that, it provides more detailed information about the variable called CM. Here it's telling you it's a numeric variable of integer type. Its smallest value that it's in the data set is 12. The largest is 312. The units are 1, meaning that it can increment by any value in 1, not by 0.5 and things like that. In terms of missing values, it says there are no missing values. STATA records missing values as a dot. So it would appear as a dot in the data set if it was a missing value. And it says there are 0 missing values out of 64. However, it says there are only 57 unique values, meaning that some value, like for instance 12, might appear multiple times, or 34 might appear multiple times, and so forth. The mean value is 141.5. Standard deviation is 75.97. Okay. I'm going to pause for 1 minute and let you guys look at this. Okay, sorry for stopping that, but I needed to make sure about something. Okay, the next is inspect. You can do that on your own. I'm going to show you the command called list. So if you do list, and then type the value of the command, like this. List CMFLR in 1/5, you'll see what it does. What it's going to do now is on screen, it will print the values of the variable CM and the variable FLR, but it's not going to print all 64 values. It's just going to print values starting from 1 through 5. So here it's listing the 1 through 5 values of it. Okay? But you can play around with this. These values. You could have said, for instance, list and just written in 1 and 5. Then it would list it for all variables in the data set. If instead you said list in 10/25, it would list the 10th observation through 25th observation of these variables. If you do the same thing, but you wanted them to appear in a different order, you could write TFR, PGNP, CM, FLR, supposing you wanted it. Then it will print them in that order for the 10th through 25th. So again, the command list is for printing on screen. You can then choose the variables, and then you can choose a subset. The subset you choose by writing the word in, and then how many observations or which observations to use. If, for instance, if you do it without writing in, it will end up applying this command as widely as possible. So what's going to happen is it's going to suddenly print all 64 observations on screen if I don't write anything there, which is fine if it's just 64 observations. But imagine if you type this and hit enter and you were working with a large data set that had something like 1 million or 2 million observations. It would be really painful to wait for it to stop because it would keep scrolling and it would not be fun to watch that. So here, if I did that, all of them get listed. Okay. There's another way of browsing the data. The alternative way of browsing the data is you go into, again, data and data editor and either edit or browse. An icon for that is also over here. You can do data editor, edit, or data editor, browse. Since we want to see this data set in its entirety, we could hit data editor, browse. Okay. So here you see the data arranged like a spreadsheet. Question is, if you can do this, why would you ever need to use this list command? Why did I go through showing you how to use the list command if you can always open it as a spreadsheet? One is to introduce you to the concept of using commands. The second is a little bit more subtle reason over here. Again, imagine that you were working with a very large data set, which had literally 1 million or so observations, and it had thousands of columns or thousands of variables. And you just wanted to know the value of some specific observation or observation under a certain condition. And you also wanted to know it only for a handful of variables. Well, if you opened it up like this, you'd be scrolling up and down the way you do in Excel, very long spreadsheet, and not knowing where to go, and it would become unmanageable. Here, you can do it very easily by using the list command. I can also do it by saying list these two, PGNP, if CM greater than 100. Now, instead of listing all 64, it's listing just those observations for which the condition is true that CM is greater than 0. So what's the moral of the story here? Command, variable or data, typical syntax. Command, variable slash data, condition or slash subset. This is the way most commands in STATA will work, and then options. Okay. So the thing to remember is that in STATA, typically we will issue a command. This will be followed by a variable or a data set. That will be followed by a command or a condition or a subset. And the last bit will be typically after a comma, there will be some sort of a option that you can give. So this will be a typical command, and so far I was showing you this command, how to use it, just for the list. I haven't done anything with the comma slash options yet. I will do so in the next few commands. But if you forget everything else and you try to figure out how to do certain things in STATA, the simplest thing to do often enough is to Google, look for help, find out how somebody is doing it, put in some keywords, and people will explain on the internet how to use that command. But if you're looking at it and it doesn't make sense, try to read it in this format, that they're writing it by first telling you what the command is, then telling you variable or data set to act on, then telling it whether to act it on the whole data set or some subset, or if certain condition is true, followed by a set of options that may be applied. And you'll see this coming again and again and again in different commands that I'm going to issue in this lecture. Okay. So we have this. The other thing you can do is type help. STATA has one of the most simplified help sections and very useful, very fast to find help. So if you type, for instance, help list, it will give you more information on how these commands are used. And you can see over here, it's got the command, the variable list, if or in condition. So this is either the condition or the subset, followed by comma options. And this is showing you how are the different ways that you could have used the list table, list command. Okay. I'll skip this part and go to the next one. The next command that we want to learn is summarize. You can write summarize on your screen, or you can write sum, S-U-M-M. Both will work equally. So I'm going to write S-U-M-M and then issue the name of these two variables, CM and FLR, and hit enter. And when I do that, it provides me the summary statistics for these two variables. It tells me here's the variable CM. It has 64 observations. Its mean value is 141.5. Standard deviation is 75.97. Minimum value observed is 12. Maximum is 312. And the same thing for FLR. if instead of writing CM and FLR, I had just written sum or summarize, it would then provide me a similar information for all the variables to which it can apply this command. So that will be all the variables in the data set that are of numeric type. If there were any non-numeric variables like strings, for instance, if this data set had also contained names of countries, then obviously there's no minimum or mean or maximum value of a name, so it wouldn't apply to that. But to all the other variables that are numeric, it would provide this information. Okay. Now, let's do an option. So I'll write summarize, CM, and detail. And now when I write summarize, CM, and detail, it's giving me the summary statistics for the variable CM as before, so these ones. But instead of just giving me these little information, it's giving me more information which was issued by using the option called detail. Telling me about its percentiles. This is something that you learned or should be learning in the slides that I've given. It's telling me the median value is 138.5. The mean and standard deviation are as before as they were listed over there. It's also telling me the highest values and the highest percentiles. Okay. So a lot more information comes out with the word detail. Okay. Let's do one more command. Let's use histogram and a variable name. So hist, I'm abbreviating it and writing CM. And if I do hist and CM, it provides a histogram for this data set. So child mortality is on the x-axis, and then it says for different ranges how many countries had a value operating, or what fraction were seeing a value over here. And it provides a very simple baseline graph over here. It's also providing some information on how this graph was made. It says that there are 8 bins. The smallest bin starts at value 12. So here it's starting the first bin at value 12. And then the width of each of these bins, it's keeping at 37.5. So it used its internal algorithm to figure out what's the best starting value and what's the width to do it. Again, in my slides that you're going through, you will find that I explain more on how to draw histograms by hand or even by computer in terms of using different widths or different starting values or different number of bins and what the rules of thumb are for choosing those. So for instance, if let me close this figure. If I, instead of using this default, I wanted to change it to hist CM bin 15, it will, instead of having 8 bins, it will break the data into 15 bins. So the picture will look a little bit more refined. Okay. I can add options to it as well. And the options that I can add could be of any type. Here I'm going to add options of the type which help me make the picture a little bit more nicer. So I'm going to write histogram CM bin 15 as before. The bin 15 was an option. Then I can put in a title which will appear on top of it. I can put an X title which will appear on the bottom, whatever I want to say. I can define the colors of these bars. So instead of seeing this brown or greenish, I'm saying use navy 8, which is an internally defined color. And then intensity being 50, so it picks the shade that I want to. You can type help and get other colors that are available and other shades that are available and play with it at your own leisure. Sorry. P color and a and there. That's the type of picture that I'll see. Okay. So a little bit better looking. And what you can also do is once you've created a graph like that you want to take to, let's say, your assignment that you're working on or a Word document, I can do click, copy, and directly paste it into something like Microsoft Word. If I was writing my report over there, Control V, and here's the graph showing up in Word, and I can make it bigger or smaller accordingly and play with it. Okay. I'm going to skip this cumulative distribution. We don't need it for this lecture. Now, creating a do file. This is pretty important to do. So when you're issuing these commands, over time, there will be need for you to start saving your commands. Why? Because you may be doing a large exercise in which you've initially created a histogram or gotten some descriptive statistics and doing some other work, and then you're done for the day, but you need to come back and do more work with it next day. But if you do it that way, you'll come back and start again from the first point onward. We don't want to do that. So what you can do is save all these commands that you've issued, the ones over here, for instance, in a do file. Here, for instance, I'm going to take the commands all the way from use Gujarati to this one, copy them, and put them in a new do file. And the do file I get by clicking on this icon, new do file, and pasting them here. Okay. Now I can save this, save as, and let's see, I'm going to save it on my desktop, for instance, for now. My first do file dot do. Okay. Okay. Now I'm going to quit STATA, and I want to, supposing, come back the next day and pick up from wherever I left off. So I open STATA, and I don't want to load the data set again and type all those commands for initiating the histogram and so on. I go into do files. The screen shows up. I do file, open, and file the find that I had saved. So here's my first do file. It shows up over here, and I can either select commands or all of it and hit run. So this is the execute selection. I've selected these commands. If I hit, all of these commands start coming out, and I'm back to here. Alternatively, I could also, in the do file, for instance, I decide that, oh, this is not a good title, histogram of child mortality. I should just say histogram, or I should say child mortality or frequency of child mortality, and I decide I want to keep everything in lowercase, 68 countries, and so on. Now I can hit save, and next time I make this graph, it will be like this. So I can just pick up from there and issue that command, and you can see that the code gets changed. So you can save this do file anywhere. It's a plain ASCII file. If you were working with someone else, you could mail it to them, or you can even copy and paste this and put it in Excel, and in your email, and send them just the text of it, and they can run it from there as well. So the do file makes it very useful. For the commands that we were issuing or working with today, I've created from before a associated do file, and if you go over here, you'll see STATA program, my first do file, STATA do second example. So there's some STATA do files that I've already put over there. If you wanted to open these, play with them later on, change some commands around, because again, the paths in it for the data set may be the wrong. They were basically based on my computer from a few years ago. You can change the path in them. Yeah. Basically, the paths in it are set for this different ones, and you can change other things about it as well. Okay. Any questions so far?
Professor, could you perhaps just go again over how you save a do file? I went to view and then, but mine is grayed out.
Okay, so you went to this part, the new do file, and nothing is over here, you're saying, right? Mm-hmm. That's because there is, you can click on it directly, so not on the drop down part, but just on the icon itself. Click on that, and this do editor shows up. Did that happen for you?
Yes.
and then you can paste all the commands that you had, and then save them as files, save as, and then save them in whichever name you want to give them and wherever you want to save it as.
Thank you.
Okay. Anybody else with any questions or any bit that I went over too fast that you want me to repeat? Okay. Let me move on. Let's look at a couple of additional
I
commands.
have one question. Like
Yeah, please go ahead.
that CM is child mortality, right? So where is it mentioned
Yeah,
like CM is child mortality? Like it's a variable label, right? This child mortality. So where is it mentioned? Is it in the like?
it's in the label, it's mentioned over here. Look, CM, and then the label is given over here,
Yeah, how
child
do we add this
mortality.
label?
Sorry, what?
How do we add this one? This label.
In this particular data set, it came preloaded,
Okay.
but if you wanted to add a label
Mm-hmm.
to a variable, I'll show you that command. I haven't yet shown you how to modify or add new labels yourself.
Okay.
Yeah, I've only shown you how to add a label on a graph, but not for a variable.
Okay.
But if you want to know, you would type label, variable name, and put in quotes something like this, or type help label. And that tells you how to manipulate labels. So you type the label, word label, type what type of label it is, variable, the label name, and then the new label. So you would type label var cm, here is a new label for cm. Now you see in here in this window I've changed it. This is how we edit the labels. Anyway, I'll go over that in a bit. This is just quickly to show you, to satisfy your curiosity, how to change the label for a variable. So the command is label. What type of label it is, it's called a variable label. Then on what to act, which is CM, and here's the new value it should have. Okay. There. Okay, and now the original data set is back. Okay, next one I want you to work with is the data set called wage 1. If you can download that from the same location. So location is, again, go over here. Here's the data set wage 1. Download it into the same location by doing save link as. And I'm doing it in my documents. And now we're going to work with this particular data set and use it. Now, if the previous data set is already loaded, you cannot load wage 1, the new data set. So you must type clear and then hit enter. So the current data set, which was on the mortality rates, has to be cleared out of the memory. So type clear and hit enter, and you'll see this area has become blank. Now the data set is ready, or the STATA program is ready to use the new data set. So type use wage 1. And suddenly a very large data set has loaded up. Well, not very large, somewhat larger-ish. Okay. Does everyone have data set called wage 1 loaded? I'll wait. As soon as you've loaded it up successfully, type done. I don't want to leave people behind, so I'll wait a couple of minutes for everyone else or whoever else is still here to load their data set. And while you're doing that, it's basically in the usual location. Go to the data set called page data 2, page 1, right click on it, download it, clear the current data set from memory, and then type done after you've done use page 1. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 people so far. 10, 11, 12, 13. Let's make it go to 20, at least 20. That's half the class so far. Okay, it doesn't look like it's going above 13. For the folks who haven't downloaded it yet, you want me to show you again any bit of it? Anyone? Okay, I'll assume that you'll get there soon enough then. So I'll move on. And if you get stuck, your data is not loading up, or you haven't been able to download it, or your connection is bad. Okay, one person's fallen behind, that's okay. Then you can always, like I said, watch this thing again, or just download the tutorial. There's a PDF of this posted up there that might be faster than watching a full 1.5 hour long video. Okay, so now learn some new commands. The first is you can again type describe to get some information on this data set. And if you hit describe, it says there are 526 observations and there are 21 variables. The names of the variables are given on the left, and the labels for them as they're being used in this data set are given on the right. This data set is actually a real data set, but just a small sample, a random draw. So in the US, there's census every 10 years. And in the in-between years, there is sampling throughout the country that goes on, asking about different types of information about those people. So here for 526 individuals that were randomly selected, we know their wage, tested in hourly earnings at a person level. So again, this data is very old, several decades old. So don't get shocked when you look at the values over there. It's given in dollars. Education is years of education. Experience is how many years they've been working. Then tenure is how many years they are with the current employer. Then there's a variable called non-white, which takes on a value of 1 if it is a non-white person, and it takes a value of 0 otherwise. So everybody's race in this data set has been codified as non-white or white, and only one variable is necessary. So the one that's kept is non-white, taking on value 1 or 0 according to this over here. There's also their gender that's recorded. The gender is recorded with a variable called female, which takes on a value equal to 1 if the observation is on a female, and 0 otherwise. And then the rest of this information is similarly coded that you can understand now how the rest of the variables are measured, the ones that are 1, 0. The only other one that's not 10 is the number of dependents that they have in the family. So that's the first piece of information you get out of this data by just hitting describe. That tells you what are all the variables in it. Okay. Next, let's learn a new command called tabulate. Now, before we do the tabulate, let's go back to sum and wage. Remember, we had a variable called command called sum. We're applying it to wage to understand what this data looks like. So it has 526 observations. The mean wage observed in this data set is 5.89 or 5.896 rather, which is almost like 5.9. So it's $5.90, you can think of it, per hour. It's an hourly wage. Standard deviation is 3.69. The lowest earning person in this data set was earning 53 cents an hour, and the maximum earner in this data set was earning roughly $25 an hour. Again, this is back in 80s or something like that, early 80s data. Okay, so that's what we get. Now, let's look at this new command called tabulate, which can also be shortened with the word tab, and type the word female. And when you do that, it tells you that, okay, we know that there's a variable called female which is coded as 10. So this tabulate command applies to all those variables which have categorical values. It can be 10 type of variable, or it could be limited number of values. For instance, if it was region that was coded as 1, 2, 3, 4, then it would apply to that. So for each category, the value being 0 or 1, for each category, it's telling us how many observations there are of that type. So when this variable takes a value 0, there are 274 observations, which represent 52.09% of the sample, which is also cumulatively the same. And when this variable takes the value 1, the number of observations is 252, which represents 47.91% of the sample. Thus, the observations, 47.91% of the observations are on females, and the 52.09% are on males, and it adds up to a total of 100%. You can now do a little bit more. You can do tabulate and combine it with the previous command called sum using an option. So you could do tabulate female, comma, sum, parenthesis, wage. What that will do is it will provide you what the mean wage is by each group. The group labeled as 0 and the group labeled as 1. So for the group labeled as 0, their average wage is 7.09, with this being standard deviation. And the group labeled as 1, which is females, is earning much lower salary over here of 4.58. 2.56 is the standard deviation, and it starts to show that there are gaps in in wage by gender alone, showing up in this data set. Okay. You can also make the observations a little bit easier to read. So for instance, you can add more commands to it. So if I add no frec, for instance, it will tell us not to print this frequency column, the last column. And you can have this type of a table, which is a little bit easier to then transport into your Word document. There are other options that we can use to make this data even prettier. For instance, we may not care about having this many decimal places. We could just want 2 decimal places. The bottom row, for instance, is telling you for everyone in the full data set what the wage is, 5.89, and then it's saying what the wage is for the males and for the females and how much standard deviation there is in it. You could do two-way tabulations as well. Two-way tabulations would be, for instance, you could say, okay, let's see how many observations we have by gender and by race. And if race was not coded as 10, but was coded as 5 different values, that would work as well. It wouldn't be any different from it. It would just have, for instance, 5 columns under the race and two rows under the gender. So here it's giving you how many observations are there in the data set by different classifications. So total are 526 observations. On males, we have 274. On females, we have 252. But then the subset breaks down by white and non-white per the cells given over here in the inner part. So for instance, on the non-white females, there's only 25 observations, and on the non-white males, by comparison, there's 29 observations. Okay. Overall, there's fewer observations, 54 observations for non-whites in general, and 472 observations for those classified as white over here. Okay. So somewhat representative of the percentage in population of how it breaks down by samples. Now, the next command is you can type this over here, which will take all of the same information as before and give you the breakdown for wage by each of these groups. So not only will it tell you what the gender gap is, what the wage, how much is the wage differential by gender, but also by race, and then by race and gender together. So here again, it's given 3 numbers for each combination. It's telling you the mean value, the standard deviation, and how many observations were in the data set that based on which these numbers were computed. So the average wage of males being, white males being 7.16 is based on 245 observations, and the average wage of non-white males being 6.54 is based on 29 observations. And same thing over here by females. On white females, it's showing up as 4.62, and for non-white females, it's showing up as 4.23. So the wage differs both by gender and by race, and for the non-white females, it's showing up as the least or the lowest average wage in this data set. Okay. By the way, so this is the type of stuff that a lot of labor economists and other people would do, and it need not be a data for the population. You could look at the data for a particular company and request that, give us all the data and give us all the demographics, and we want to see whether there is a wage differential within an institution or within an organization or firm by either gender or race. And what you will learn during these regression modules in the next term is that you can then see whether these differentials keep on persisting even after you take care of other differences in them. For instance, what if you control for their years of education and years of tenure and years of experience? Then you would expect that if there is no wage discrimination, then the averages should become the same after controlling for those. But if the averages are still there, even after you've controlled for the experience or training or years of education and any of those things, and the differences keep persisting, then you can say, okay, are the differences statistically different from each other or not? And if they still are different from each other, then you have a very solid evidence of wage discrimination going on in that organization. And that's again, how to do the actual statistical test of it is in the morning lectures. If you work through those slides, it shows you how to do those type of tests and how to control for other things. Well, controlling for other things is not in the morning slides. That's something you'll learn more in the regression analysis once the term starts. But the baseline descriptors, you can get it like this. Okay. You can also get rid of these frequencies over here and get rid of standard deviations if you just cared about getting the mean values, because you want to copy and paste that into your, let's say, Word document as a report, and you don't want all these extra numbers over there. So it makes it like this much easier to do, and then you can round them off to 2 decimal places. Okay, I'm going to stop over here, but just before I do, I'm going to tell you how to think about the labels. There are 3 types of labels in STATA, and you can play with the labels command on your own after this session is over. But the 3 types of labels are: first label that allows you to put a label on the data set, and that's, for instance, over here we had label in the describe. This particular, well, this one didn't come with any label, but the previous Gujarati one had a label associated with it. Then there is the second type, which is the label for the actual variables, which you're seeing over here. And then the third labels are what are called value labels. Value labels are that, for instance, if you look at tab or do, let's say, list female and wage in 1 in 10, it takes the values of females as 1 or 0 over here. You could keep these as numbers so that you can do arithmetic and statistical analysis on it, but you could put a label on the values themselves so that when you print it or somebody is looking at it on screen, instead of typing the word 1, 0, it types the word, whatever word you want, for instance. So it could type the word female here and male here or some other thing. So you could change the value labels. And those are, the way you describe it is you always first issue the word label, then you either follow it with the word data or variable, or for the third type, you have to define and then use values. So label values, label variable, or label data. And this example is showing you how to change this output so that instead of 0 and 1 being over here and 0 and 1 being over here, you give them some actual nicer looking labels. And you also change, rather than it being called race, simply you can put whatever the label for it is and then change the name over here to be fully gender. Then it will print as male, female over here, white, non-white over there. Okay, that's the basic lesson for today. I'll pick up from here whatever's left over tomorrow, and then we'll start doing some exercises based on the ones that I've posted on the module Blackboard website. So if again you go over there into the session over here, you'll find in the previous folder assignments, and in the assignments you have exercises based both on the morning lectures, the theory part, as well as exercises that are based on working with data sets. So here it's telling you to load a particular data set and then do certain exercises about it, which we'll pick up on in the next lecture. Okay. Any questions?
Yeah, sorry. Did you mention or did you say that those exercises regarding STATA should be done prior to tomorrow's lecture, or did you say that they are going to be going through them in tomorrow's lecture and onwards?
I'll go through them tomorrow in tomorrow's lecture. I'll first finish part of this exercise a little bit, and then I'll start on one of those STATA exercises.
Brilliant. Thank you.
Okay. Again, if I've gone too fast, I apologize, but like I said, everything is written over here. Once you've got access to this file, which is posted there, even if I'm not there, you can work through it on your own, because everything is written command by command, what you should type, what you should expect, and what's the logic of that command, how it's working. So I'll see you all tomorrow, first in the morning. Please log on. At that point, we'll discuss the slides and the theory questions that are there. And then after that, in the afternoon, again, we'll pick up on the STATA issues. Okay, with that, I'm going to log off. Thank you very much for attending today. And I'll see you tomorrow. I'll stop recording now.